so now let's see an example of the third technique, where m and n are both even non-negative integers, and we're going to use half-angle identities to transform the integrand into a polynomial in cosine of 2x and apply the preceding strategies once again to powers of cosine of 2x greater than 1. Well, that's a mouthful. All right, so let's see what's going on here. All right, so n is the power of cosine, and you can see that n is 4. But what about m, you ask, the power of sine? Well, since there is no power of sine, it's 0. 0 is an even number, so these are both even, so this will work. Right? This is the technique we're going to use. Okay, so technique number 3. Now let me remind you about what the half-angle identity says. So the half-angle identity says that the cosine squared of theta is equal to 1 plus the cosine of 2 theta over 2. Okay, so I'll be back for you. Hold that thought. All right, so I'm going to rewrite my integral. Rewrite my integral as cosine squared of 2y squared dy, right? Because cosine squared is cosine to the 4th. Now, here's where the fun begins, because cosine squared of an angle, 2y, that would put cosine squared, my angle is 2y, my theta is 2y. And so that would be 1 plus cosine of 2 times, now where there's a theta, you put in 2y. So if I write this way, cosine squared of 2y is equal to 1 plus cosine of 2 times, and theta for me is 2y all over 2. So that'd be 4y. So that's what I'm going to use. So I'm going to say that this is equal to the integral of, and where there was cosine squared, I'm now going to use this. So 1 plus cosine of 4y over 2 all squared. And that's because of the half-angle identity. All right, now I know that seems like that's not helping at all, but it is. 2 squared for starters is 4, right? So that'll be 1/4 integral of, and then I'm going to expand that numerator. Well, let me write it this way. 1 plus cosine of 4y squared means I'm going to multiply it by itself, like that. All right, so now let's take a moment and actually expand that and look at what that looks like. So 1 times 1 is 1. Cosine of 4y plus another cosine of 4y makes 2 cosine of 4y plus, and then I have another cosine squared of 4y dy. All right, so far I'm doing well. I know how to integrate 1, no problem. I know how to integrate 2 cosine of 4y, no problem, easy substitution. Cosine squared, that's looking familiar. That looks like I got to do this again. So if I had the cosine squared of 4y, that would be equal to 1 plus the cosine of 2 times 4y all over 2. So I'm going to use this and substitute it in for this piece. So let me rewrite this one more time. This is equal to 1/4 integral of 1 plus 2 cosine of 4y plus, and then cosine squared of 4y is going to turn into 1 plus cosine of 8y, because 2 times 4 is 8, right there, all over 2 dy. All right, so I can break this up. I can break that numerator up one more time. So this is 1/4 integral of 1 plus 2 cosine of 4y plus a half, right? Because 1 over 2 is a half, plus the cosine of 8y times a half, right? It'll just be easier if I put the half out in front of that rather than trying to write it all over to dy. right? All of that is the integrand. But I know how to integrate all of this, so this is no problem. So let's see here. 1 plus a half is 3 halves. I guess I can take one more step. So 1/4 integral of 1 plus a half is 3 halves, and then I'll write it like this. Okay. So we use that half angle identity twice, right? Just one more time. That's another half angle identity right here. So we've used it twice to make this work. But now we're finally to the point where every single piece of this is easy to integrate. Okay, so okay, 1/4 out in front. And then the integral of 3 halves would be 3 halves x plus. Now the integral of 2 cosine of 4y, remember the integral of cosine is sine. So it'd be sine of 4y. And then we need a 2 out there because it was already there, but we need to divide by 4 in order to make that work, right? Because there was a 4y inside here, and so if you took the derivative, you'd have chain rule, and you'd multiply by 4. But I don't want a 4, so I divide by 4. Plus, in other words, it's U substitution. And then here I've got the half sitting there, and then the integral of cosine is again sine. And it'd be 8y, but I don't want the 8, so I'm going to multiply by 1/8 right there. I'm just going to add c. All right, so let's distribute a little bit. Let's combine and simplify. 3 halves times 1/4 is 3 over 8. So we have 3 over 8x. Oh, is this all y? Did I just switch to... Oops. It was y. Sorry. That's y. Y. There we go. 3/8 y plus 2 goes into 4, a half, right? So it's 2 into 16 if you want to think of it that way. So it's 1/8 sine of 4y plus, and then 8 times 2 times 4 is 8 times 8, which is 64. So it's 1 over 64 sine of 8y. There's that integral. So it's a little bit more tricky because we're not as comfortable with the half angle identities, but they're key to making this method work. So we had to use the half angle identity not once but twice. We used it once here to make that cosine squared turn into this cosine 4y. And then we ended up with another cosine squared, and then we had to use the half angle identity again. And then once we got here, it was just a question of simplifying things down and then taking some very simple integrals using, of course, the techniques that we know that if you have the integral of, say, the cosine of ax, that's just 1 over a sine of ax. And I'm using that all over the place to get the 1/8 here and the over 4 divided by here.